Well, hello everyone and welcome back. This is going to be lecture 12, and in this lecture, I'm going to be covering the switch operator continuation of it. And I share another example, just so you don't get stuck in this idea that there's only one way you use switch. And another example will help you kind of broaden your horizon. And then I'm going to get to call by value and call by reference. Call by value and call by reference is mainly used when we call methods or functions. So I'll show you some examples of that. Header and implementation files will be towards the end. This is going to really set up the stage for us to get into classes. If well, I'll use this example once I get there. So without any further ado, let me just jump right into the switch operator, and I have an example that I wanted to share with you. Close this Jira. That's for my work. Um, okay. So last time we saw the an example where um, it took in an operator, right? So you see in an operator from the user and two numbers, and based on what the operator is, add, subtract, etc., you do your calculation. Well, in here, it's slightly different. Okay. So you still have a character, but in this case, it's character grade. Okay. So based on what the grade that you enter, um, it's going to tell you if if it's excellent, well done, you passed. Better try next time, invalid grade. Um, let's do this. Okay. So I didn't declare it. So go ahead and declare it. So I'm going to say A. Excellent. Your grade is A. Similar to what we have, and if I put in 1, invalid grade. Your grade is 1. I mean, it's still going to output that character, but if it's not A, B, C, or D, then it's going to say invalid grade. Say F. Better try again. Your grade is F. All right, so if it's A, it's going to say excellent. B or C, it's going to say well done. D, it's going to say you passed. F, better try again. And if anything else, it's going to say an invalid grade, and it's going to output what the grade is towards the end. Now, see, once again, we're still using the switch operator, and we're taking an input from the user. Okay, so you can use this switch operator for any scenario, any case anytime you come across an issue and you think the switch can be used. One way to go about this if I go back to the previous program, we noticed in there that there were lots of if then else, if then else. I always say if then else, but it's actually written if else, but I just refer to it if then else, if then else, etc. else followed by something else. You know, that is a number one indicator that instead of having so many if then else's, you need to go to a switch statement. And if you recall, it's mainly for readability perspective and also to be able to maintain the code in the future. It's going to make it much more easier for the future developer who comes in and looks at that code, be like, oh, okay, I know this is clear and straight and to the point. So if you're writing code, see like you start typing in if then else's, chances are you want to go to a switch statement. And I'll remind you of this again. Always use have a default for the when you have a switch statement. Okay, it's going to save your life. Not literally, but it's going to be a big help for you in the future when you're actually developing code. So that's one. Okay, so that concludes the discussion about the switch operator. It's another example. Um, the next thing is call by value and call by reference. And as I alluded to earlier, it's used in arguments to a function. So whenever we call a function, we pass in arguments or parameters, right? They're either called arguments or parameters to the function, and they're either called by value or they are called by reference. Now, um, one of the things that we didn't cover up till now is the call by reference. Actually, we didn't even cover call by value. Let me talk about what call by value is. If you recall in the past when we did the example, and instead of this, when I had the switch statement in a function and I was calling it call by value. Now, if you don't see any special characters before or after the argument or method, chances are it's called by value. What happens is when you call a function this way and you pass in those two arguments, what happens is a copy of those two arguments gets passed to the function. And any changes in the function that you make to the parameters or those arguments do not impact the original variable. And not to worry, if you're getting confused, you're going to see an example that's going to make this much more clear. Okay? So if you have call by value, you get copies of the parameters, and anything you do to those parameters and one is not going to impact those main variables in the sense that so if once you leave the method and you're out of the method, any changes to the parameter will not get reflected after that. Whereas in call by reference, a key indicator here is you'll see the ampersand sign or a pointer or an asterisk before it, which is going to signify that it's call by reference. Now, what happens in call by reference is when you pass those arguments to the function, instead of what the compiler is going to do, instead of having a copy sent to that function, it's gonna pass a reference to that function. So think of it as in memory location XYZ, you have a variable or you have an integer I. Now, when you call a method and you do call by reference, you're actually referencing the same memory location. So a copy does not get passed. It's a reference to the actual memory location. And any change you made to the parameter is going to impact the original variable. So after you've exited the function, and if you've used call by reference and you've made changes to those parameters, those changes will have an impact even after the call to the function. Okay? That's a whole lot of words there. Now let's go and see an actual example. This thing is still running. Control C, take this out, Control A. The other day when I was trying to write this program, there was something wrong with the compiler. It wasn't compiling it. It looks like it's still stuck from that time. Let's leave it. Let's focus here. Okay. Now what's going on in this method? It took care of the compilation statement or issue. Include IOStream using namespace std. Okay, that's your usual notation. Now, here is void swap int x int y. Now, if you recall in one of the previous lectures, I didn't have this in here. And and when I got to the main function, what happens is, let's say if you don't have it in here, first of all, your program isn't going to compile. And when you come down here, it's going to look at, okay, you're calling a method called swap, and you're passing it two integers. I have no idea what swap is. It's going to come later on, but it doesn't know right now. So what we do is we tell the compiler, hey, look, before the main method, that there is a method of this signature whose return type is void and takes in two integers. So the compiler is not going to complain. We ran into this issue last time, and that's how I was able to fix it. And then notice here, after calling the swap method, I'm outputting the values of A and B. Okay. Now in the swap method, what am I doing? I take in x and y, which was a and b, 10 and 20. I say t equals x. I have an integer t, which is going to hold a value x. And then I'm going to say x is equal to y. And then y is equal to t. So essentially what you're doing is you're swapping the values for x and y. And then here I say, hey, value of x is this and value of y is that. And see what happened? A was 10, B was 20. But when I came here, x became 20 and y became 10. I swapped the values. But notice what happens here. After the swap method, A and B were still a little bit more legible. Now, A and B still had those same values after you called the method. You swapped them, but that swap didn't have an impact after the call to the method was terminated. All right. This is an example of call by value. Right? You don't see the ampersand or an asterisk. An asterisk is like when you see that asterisk, it's actually a pointer. So I'm going to refer to it as a pointer, and then in your mind you can think of it as an asterisk when it's written down. So A and B. Now what the compiler did was in calling this method, it made a copy of A, it made a copy of B, it then sent it to this method. That's why in this method, when you swapped it, you saw the swap actually did take place. However, when it came back here, A and B were still the same. A was 10 and B was 20. Now watch when I change the method signature. Now, like I said, ampersand meaning call by. Okay, now watch this. I'm defining a swap method here that takes in two integers, but this ampersand sign meaning it takes in reference. It's a it's going to take in reference parameters. Same thing here, right? I've in the method right here, I put an ampersand, so those are actually references to x and y. Now, when I call the swap method, I call it given it the parameters a and b. Now watch this time what happens. X and y, the value was swapped, so 20 and 10. But look at a and b, what happened? In the last example, a was 10 and b was 20. But in this case, a is 20, b is 10. What happened there? Because even though a used to be 10 and b used to be 20, now it's actually swapped. But I'm printing out the values after calling the swap method. So when you gave it a and b, right, these x and y are actually um, pointer in the memory location to the actual object. So when you did x equals to y, you said, hey, now x, you're gonna point to wherever y was pointing to in that memory address, whatever the memory address it was. And the value that's in it, now it's x's value. X is equal to y. And y, what y is going to point to, it's going to point to t. And t was x, right? So now you've swapped it and you output it. But when you've come back, since you actually had a reference, you had a reference to that memory location, you knew what was in there, you actually changed the contents. So the original content of A and B also got swapped. Okay, so this is a great example for call by value and call by reference. Okay, now let's continue on with our next topic. Let's jump right into it, the header files and implementation files. Now this is gonna come in handy when we get into classes, but this is a good introduction right now into the header files and the implementation file. What happens essentially here is um, in your header file, you have the function prototypes, the definitions of the functions only, and uh, in the implementation file, you have the implementation of the function. For example, the signature of the method can be, um, let's say if it's square root method, right? So you'll say it's a square root method, it returns something, and it takes in these arguments. And in the CPP file or .cc or the implementation file, you're actually going to have the nitty-gritty of the function or that method, exactly what it does. And like I said, going forward, once we get into classes, you'll get a chance to see um, that the definition of the class is in one file and the implementation is in another. But here, for this class, just to kind of keep it simple, I'm going to build on the swap function, and I'm going to go ahead and create a header in the CPP file. And while we're on the topic of this, one of the things to keep in mind is the if and def and def. So the pound sign right here, um, actually, let me show this via an example here. So anytime you come and you're in a class, I shouldn't say you're in a class, you're in a program. What the compiler does is before it starts compiling anything, it the pound anything after the pound sign takes precedent. So the first thing it does, it'll look for the pound include, and it'll include this IOStream file. And the way it works, it literally pastes the IOStream file on top of this main function. You don't get to see it, but it's there in the background. So the first thing the compiler looks at are the pound, uh, anything after the pound. Okay? And what this means is if not defined. So you start off with pound, if not defined, and in it you have the definition of the function or definition of the class. So you will see if not define name, name of something, and then you define it. Okay. So the way I'm gonna go about this is let's look at our swap function right here. Um, okay, this session froze. I'm gonna go ahead and open up a new one. Erase Mazhar. Nope. Open it up. Oops. I typed too fast. Okay. Okay, so now in here I have I'm gonna, let me show you this. I have this swap.h. So I have created a file called swap.h. And if you see here, it says if not defined swap.h, define swap.h. Okay? Yeah, this is just being safe. If it's not defined somewhere, because you could have, as you have more and more files in your directory, you could have uh, a file out there that's called swap.h. I mean, right now I have a few files only in this directory, so it's not a problem, but you could run into this issue. So you tell the compiler, look, if the swap.h is not defined, then I start defining it. And the define ends with endif, okay? If and if, okay? It's not defined that ends, I should say, the if statement, this is the end of the if. Okay, so think of it as open parentheses, close parentheses. So we define swap.h, and in it I say include IOStream using namespace std and void swap. That's all I have in here. Void swap int ampersand int ampersand. That is the signature of the method. That's all I'm saying in this header file is there is going to be a method somewhere, okay, of the signature. It returns void, but it takes in two integer and it's a call by reference. Okay, escape. And then I have swap.cpp file. Let's see what's in here. And in here, what I do is include swap.h because even though I'm implementing this function here, the header, the signature of the method is in the .h file. So I include it right here. And I say include iostream void swap, and essentially I have the same thing what I had in the swap method. So all I did was I took the swap method and put it in a header and a CPP file. The same thing. If you go back to here, right, I had the function prototype right here, and I had the implementation right here. And I've separated those out, and you're gonna find this kind of representation very useful. Um, and the code becomes much cleaner, compilation, debugging, etc. There are numerous benefits of having header files and CPP file. Um, this is in Unix, and you'll also be doing this if you're using an IDE like Visual Studio or anything of that nature. Um, oh, I don't. Do I have the couts in there? Oh, one thing I don't have are these two couts. So I'm swapping the values, but I don't have the cout. So that's the header file and the CPP file. Now, you might be wondering, okay, great, you've got a method. Where are you using it? Where are you calling it? Okay, and then besides the header and implementation, you need a driver file. In my case, I call it main.cpp. Escape main.cpp, which is the driver, because you need a driver or a main method, the int main that you always look at. This is here. So in int main, I include swap.h, okay, and a is 10, b is 20. Then I call the swap method. See, the implementation of swap is not here, but what it's going to do is when I say swap.h, it's going to copy paste that file here. So essentially, you have the same thing as here. So you end up getting this void swap. I'd say a equals to 10, b equals to 20, and then swap a and b. And after I've called the method swap a and b, I output its values. And keep in mind, it's called by reference. So are the values of A and B going to get swapped? Yes or no? Take a guess. Um, the way you compile this, CPP, you have your main function, and then you have your swap, okay? Because the main function knows about the header, but it does not know about the CPP. So when you compile the main and swap together. I said CPP, but I typed in C++. That's what happens. Okay, no errors, nothing. And the way you run it is main.out. A is 20, B is 10. And if you guessed that the values are going to be swapped, you were correct. Because it's a call by reference, and in call by reference, sure enough, uh, the value will change even after you're out of the method, okay? Hopefully that is clear, separating out the function prototype and its implementation in two different files, and you have a driver. Okay, when I say driver, I mean you need an int main. You need a main method that's actually going to call the swap method, use it. And the way you go about compiling it, CPP main, which is your main, you can say you could have said swap.cpp. It's going to do the same thing, right? It's the same impact, or main.cpp, main.cpp, swap.cpp. So when you're compiling these files, you don't compile the header files. Um, I shouldn't say you don't compile it. They get compiled as part of main because in main you included the header file, and then you compile the swap.cpp together. That's the way you go about compiling it. The compilation part can be a little tricky though because um, I'm explaining it. And right now it's going to make sense, but when you start writing a program, you're like, oh, shall I say .h or .cpp? What do I compile? If you're getting confused, take out CPP from there. Have your driver and the class. This is, I have one class, but you could have had multiple swap 2, swap 3. Assume I had header and implementation for swap 2, swap 3, swap 4. So I had a method, a swap method with different variations, right? So there was a swap 2.h, swap 2.cpp, swap 3h, and 3cpp. Same thing for 4. So you would combine all of those together. Yet you will only have one main. Okay, you can't really have two ints theoretically. Okay, you have one main driver that's calling these methods. Okay, hopefully that's clear. Have a good one now. I'll see you guys next class. So the midterm's coming up, so make sure you prepare, and it's gonna cover everything up until the last lecture, not this one because this one is it's kind of late in the game for you to go over this and study for the exam. So up until lecture 11 um, is what's going to be included in the midterm.